Good evening, all, and welcome to the second online tutorial video series for this topic, Explainable AI. And today we are going to see about perturbation-based methods. That is, in the last video series, we see about what is the importance of explainable AI, why we want to explain different AI algorithm, what is its advantages, how to make the things better to the customers. These things we have seen in the first lecture. That is, what is the fundamental or base. So in order to explain the already existing models, that is called, we already explained you, that is what is called as black box models. So that are very hard to understand. That is, we don't know what is behind the operating procedures, protocols, how the algorithm is working, how the neurons are firing, what are the different protocols they are using in predicting the data. These things we don't know actually. These are very hard to understand also. In order to make this it clear to the customers as well, that is the stakeholders, we are going to develop some algorithms that are called as interpretable model. So that is called as interpretation. So how we are going to explain the things to the customers in a satisfied manner, that is called as local interpretable model. We are a model that can able to explain, or it is transparent to everyone, then that is called as a interpretable model. So in this session we are going to see some of the perturbation based methods. What is called perturbation, that we will see in one by one. So some of the methods are there. In that I am first taking local interpretable model agnostic explanations, that only we are going to take for today's discussion. That is shortly called as LIME. You can see here. um, okay, this thing will work. Okay, so you can take the first letter L, and this is I, and this is M, and this is E. So shortly it is called as LIME. In explanational machine learning model, we are calling this as LIME model. So this is a local interpretable model. This is not global. In the first unit itself, I explained what is meant by local and what is meant by global. Local means out of thousands of data, it will take a single data and it will explain on what basis the predictions are made. That is called as local interpretable model. So it is used for certain things like patients. Mostly explainable AI models are very suitable for medical based applications, since that are all very sensitive. We have to explain each and every criteria. For that purpose, we are the only one trust the AI has to gain is only one sector, that is called medical sector. If it gained the trust means, then AI is the one of the best collaborator in diagnosing the diseases. So in that aspect, what we are doing, we are going to learn about what is meant by local interpretable model agnostic explanation. Simply call it as LIME model. So these are all the things. So let us see what happened. So generally, the complex models like deep neural networks or any neural network combination, it is very difficult to understand. We cannot able to understand how it is working, on what basis it is predicting. That we are not unable to understand. It is not our work also. It is very hard to understand, especially for non-engineers. They don't know what is meant by neuron. They don't know what is meant by firing. They don't know what is meant by bias. Explaining all these things to the customer needs simplification. We need to provide them raw data. This is the thing. This is the thing. This is the thing. Like that. We should not tell in a technical manner. So for that, what we are doing, we are going for certain new technique. These complex models are globally non-interpretable. That is, we cannot tell on and average this model is working like this. That is very unfortunate. But we can take only one instance. We can work out and we can tell certain predictions are going on like this. We cannot understand the entire model. But we can take a single instance and we can explain. That approach is called as Lime approach. So it is locally, it will take one instant and it will explain you in a very elaborate manner. That is called as Lime model. So in this online session, we are going to see in a very, very elementary level. That is, if you go in a research level means you don't understand. After learning this, if you read one research article means you can able to get into the idea. So what is meant by weights, how it is adjusting the weights, on what basis it is giving high weightage, low weightage, what is meant by contributions. These all things will clear to the followers who are following this video. Okay, so next, in order to explain you in a simple manner, we are taking one small model, a mountain range. On an average, this is called global shape. What we are showing here is called as global shape. So I will 1 minute. Okay, so fine. So these are called as global shapes. Global shapes are very complex to understand. You can see here many ups and downs are there, many complex geometries are there. We cannot able to predict what is the shape. It is a triangular or what is this line or circular. We cannot tell. But if you zoom it to a particular small point, small tiny point, you can see it is a straight line. You can see here. This zooming portion only you can see a straight line. So we can apply any simple linear approximation to view that what is the thing, how it is prediction. By sampling all the thing, we will able to recognize or able to analyze the model. That is, instead of taking the entire values, I am taking only one small instance and then I am going to predict based on this, I am going to tell one by one. So this is how this model is working. So here I have explained this. So complicated shape globally, but if it is zoomed to a one tiny spot, it looks almost flat. That is, simple approximation is possible. We can explain. Okay, this the base will be a straight line. Like that we can explain. This is a simple example, but we will see one by one. Hope this diagram is quite useful to you. Next, for doing the line, we are having several steps. What are the steps? Let us explain. First, we need to select the instance to explain. For example, we are having 1,000 patients. Out of we no need to explain all the 1,000 patients. One patient we need to take into consideration and we need to explain to him why this prediction, what is the meaning of the prediction. So here you can see the example. Patient X with prediction 0.85. So if you give the data means model will tell you 0.85, but that patient don't know what is meant by 0.85. So in the house, for example, medical agnostic system, if I am giving my age, my blood pressure, my cholesterol level, everything I am giving means the model will tell you 0.85. But that 0.8, just like a X-ray, on the last class I explained, na, if you take one X-ray means you can't understand this. Until medical interpretation involves, you cannot be able to understand what is the meaning of the signals, what are the different levels of the signals, we can't be able to understand or interpret. Similarly, if your model is giving one reading that is 0.85 means the patient don't know what is that. So instead of that, 85% probability of heart disease you are having. So if it is telling also, a patient will get confusion. How this model is telling 85%? I am doing regular exercise. I am having a good habitation, a good eating practice. Every day I am going, drinking water. What are the medicines doctors are giving that I am regularly taking? Everything I am following. Then on what basis you are telling that I will have 85% of probability of heart disease? These things a patient may ask. So for that purpose, what we are doing, we are going to take the patient sample and we are going to interpret the decision made by a black box model. It may be any model. like random forest, radar boost, anything it can. But we are going to interpret how that model is gives that decision. We are going to see. So for that, what we are going to do one important thing that is called perturbation. What is called perturbation? Many in the accent may be different. Perturbation, perturbation, many things they may tell, but actual word is perturbation. Perturbation is nothing but what? We are taking one sample and we are going to generate synthetic data. Synthetic data means what? Means dummy data we are going to generate. We are going to vary the each and every quantum by small variations. And on and average, if you test everything means, if the same contribution are coming into the picture and ultimately one factor is the highest contribution means, we can tell that due to this reason only I am telling like this. This is called as perturbation. Perturbation of sampling means we are going to generate synthetic data. That is, one instance you are giving means the line model will generate 10 instances in and around the boundary. What I am telling is, if I want to explain clear means, if I am giving age as 55, okay, here itself it is there, no need to write. If age is 55, then the instances will create like this, in and around 55. So before 55, after 55 and around, in and around, that is called circumstances. So 55 is the center, and around that, what are all the nearest numbers possible? It will generate 10 datas. That is 54 except 55. Since 55 is the given instance. Okay. So 54, 56, 53, 58, 59, like that it will generate. Like that 10 datas or even 100 datas it will generate, depends on the design of the model. Similarly, cholesterol level here we are using 240. 240 means in and around it will generate. You can see it will leave 240, remaining 235, 245, 230, 250, like that it will generate. So this will create a local area around the original prediction. What we need, if I want to predict based on age 55 means around that, what are all the local prediction possible? It will create synthetic data. These are approximate only. We cannot tell that for 55, this is the prediction, this is the thing. Not. If we vary means what is the contribution that we are going to check. Based on that, we are going to justify. This is the main thing that is called as agnostic principle. We are going to justify. Okay, on the given all these variations, highest contribution is this. So based on this, I am giving this. Like that, we are going to explain. Okay, so I think it is clear. Next is third step is, and that synthetic data we are creating. Now, original data set we are not disturbing. From that, we are taking one synthetic data. We are generating in and around boundary some 10 or 15 data we are synthetically creating. Then it approximately become a synthetic data model, and what we are doing, we are giving again to the original black box model. Same black box is going to test this synthetic model. This is just like a virtual simulator. Dummy waveform, dummy data, we are giving it to a testing phase. Just like testing and training, here we are going to test. So we are giving a synthetic data that is called perturbated samples. These are called perturbated samples, that is synthetic data. These are given to the black box neural network. And what are all the predictions made by the black box networks that we will record? And we are going to perform approximation of weights. Original weight is what? How the samples are far away or nearby, like that we are going to adjust the weights and we are going to justify the prediction. Okay, this is step number 4. And finally, we are going to train the simple interpretable model. It may be either linear regression, whatever it may be. So the weight ensures it focus on only the local region. And finally, what happened? Positive coefficients coming means future has increased disease probability. Negative coefficients coming means future will have a decreased probability. So you can see plus 0.04, plus 0.2, plus 0.16. So positive, highest positive contribution, highest disease probability. Less positive, less negative coefficients, it will reduce. In the loan problem itself, we see how the contributions are working in the same manner only. That is just a extension. These are extension and application based. So these are the fair theory behind the line model. Now what I am going to do is we are going to see one simple numerical example. Whatever I am telling, these are just a words, how it will happen. Okay, I am telling, he is telling, we are going to take instant, we are going to take boundaries, and we are going to test, we are going to train. It will create positive coefficient, it will give negative coefficient. He is telling something, but how these are all possible? That question will come. So in order to interpret that, we are going to take, this is the formula behind the mathematical equation behind the line model, but we are not going to concentrate on this. But even though you are going to understand what is the meaning of this mathematical model, that is line function of x, new function is equal to minimum of L is nothing but loss function. F is the complex black box model. Whatever the prediction we are giving, that we are going to take simple interpretable model. After that, what is how the interpretations are done, and then what is the distance between these two, weight based on distance from one point to another point, how much distance, it is close or far away, these things. And after that, complex penalty. In order to keep this, we are making this ohm or bias, whatever maybe, we are going to keep it as a simple value. Based on all these things only, this line is going to work. But we are for explaining all these things, we are not going to take this model into this equation into consideration, since it become very complex. It can be computed by the computer only. If you work on this, means it will become 6 to 7 pages. It is we cannot even understand also. That much high computation human cannot perform. So in order to make the things understandable to the learners in a simplified manner, what we are going to do is we are going to take one small manual line example. Those who are writing UG examination or want to understand what actually the line before going into research aspects, this video will be helpful what simply a line is doing. This is not actually the high level computation. This is a low level computation just for created for understanding what is meant by line. Based on this aspect, you can read the research paper so that it will be understandable to you. So here also I am taking heart disease prediction. Why I am always depending on medicine means, this already I told you, this AI is struggling to gain trust in the field of medicine. No one is relying. That's why serious research aspects reviews are happening to make the explainable AI or AI mechanism one of the trustable partner in the field of medical science. So in order to do that, we are relying more data sets. We are training the AI models more to understand more sensitive data sets. These things are happening in the research aspects. So here what I am doing is, first we are taking a feature that is X1, X2, X3. Three features I am considering. This is toy data only. So only three data I am considering. One is age, another one is blood pressure, another one is cholesterol. These things I am taking. So before going into this, you need to understand what is all these parameters that I will tell you in the upcoming slide. That is, probability of heart disease will be from 0 to 100. So 100%, 68%, 50%, 10%, depend on the prediction. So this is dummy model for line practice. Okay. So first I am going to this called perturbation. So what is perturbation? I will tell you in the instantly I will tell you. So first I am taking one small instance. This is the given actual data. Age is 54, BP is 130, cholesterol is 240. If I am giving it to a black box model, then the model is giving output as 68. This is the probability score. The person is having 68% of heart disease. So what is the customer question? Why 68? Why it not 40? Why it not 80? Why 68? How will you arrive particularly 68? That value, how you are arriving? Usually some values randomly it is projecting, means what values it will project: 60, 65, 70, 75, 80. Particularly it is generating 68. On what basis you are generating 68? That is the question asking. We are asking. We are also asking why 68? On what basis 68 is coming? How this probability score is calculated? So here we are going to explain that. So there are what I told in the theory. It will take the instant and it will create a local neighborhood values. You can see here. Okay, so here you can see this is S1. This is the actual real data. Okay, so here I am giving 54, 130, 240. What is the actual value in the data set, original data set? I am just taking here. And this S2, S3, S4, S5, S6, these are the another 5 synthetic data created by the line. This will create how 54 become 55, one increase. 130 or 240 are maintaining same. Next, what it is doing, reducing 1, 53. 130, 240 will remain same. Next, it is taking 54. What happened here? 54, 54 same, but 130 becomes 140. It is increasing 10. And then 240 will be same. Here 54 same, but it is decreasing 10. So 120 will come. This is the base data. From that it is increasing 10, decreasing 10. And then here, so here what happened? S6. Here these two are same. Here it is increasing 10. With that the data we are stopping. Okay, so S6 only we are considering. S7, S8, S9, you can do up to many probabilities you can consider. But for simplicity, toy data set, I am considering only 5 samples. Okay. Next, it is clear, I think so. Okay. So just variation of the data slightly. 1, 2, 1, 2, like that flipping. So this synthetic data, let us assume that Lime is creating the synthetic data for 5 samples around the neighborhood of real data. 54, 130, 240 is the real data. Around that, it is creating the variation by varying small instances. The synthetic data are generated. This is called as perturbation. These are called perturbation data. Okay, perturbation data. Next, what we are doing, black box prediction. So if you give this perturbation data to a black box model, for example, linear regression model, random forest model, AdaBoost model, anything you just give all these values to a black box model, what is in your hand. If you already trained model is there, now you can give it and test what it is telling. For S1, it is giving prediction as 68. Already I show you 68% of heart disease. This is original. S2, S3, S4, S5, S6. For this synthetic data, it is generating the prediction 71, 65, 75, 60, 70. Fine. We are recording that values. Next, what we are doing, we are computing the local linear model. That model we are going to difference. We are going to find activation model. So B plus linear regression, simple linear regression only. B plus W1 X1, W2 X2, W3 X3, like that linear model. Next, what we are doing, this is the important step. One by one, we are going to solve. Solve for weight W1. We have to estimate the weights. This is important step in the line. Understand carefully. So 3 parameters are contributing parameter. One is age, another one is cholesterol, and another one is blood pressure. First, I am taking age into the consideration. So what is the thing? First parameter you can see age is 55 for sample 2. Original data is 54. S1 is 54. So here you can check. S1 is 54, S2 is 55. These two samples first I am considering into for analysis. So only age only. So here I am writing the expression B plus 55 into W1 plus 130 into W2 plus 240 into 73 is equal to 71. How I am writing this? You can see here 55 W1, 130 W2, 240 W3 is equal to 71 into 71. Similarly, S1 is the given equation 54, 130, 240, 68. This is the original sample. For the age of 55, this set. For the age of original age of 54, this is the set. Bias will be same. Now what I am doing, you can see here 55 and 54 are the only difference. Only one parameter is varying. How much varying? 1. Understand, 54 55 difference is 1. So I am subtracting S2 minus S1. So what happened? W1 is equal to this weight. This is 1, right? So W1 is equal to 71 minus 68. These two are cancelled. So remaining is what? 3. What is the indication? If W1 is equal to 3, that is if I increase age by 1 year, if 54 become a 55, then the risk score is increasing by 3 times according to the model. Heart disease score will be increased 3 times based on age. Fine. If age is increasing from 53 to 54, sorry, 54 to 55, the age is increasing by 3 times. If 55 to 56, the age will increase 6 times. 3 times it will increase. Score will be increasing by 3 times locally based on the assumption. Fine. Next, we will compute in the same manner. S4 and S1 I am taking. What is the variation? So you can see here 54 is same, but here what happened? 130, 140. 10 times there is a deviation. So what is the meaning of this 0.7? For every 10 mm increase in the blood pressure, the score will be increased by 7 times. 120 mm is normal systolic pressure. 130 mm is mildly elevated, light elevation. 80 mm is the normal diastolic pressure. These are the medical terms. Before understanding, you have to very much work on the medical terms first. Then that will be easy for you. So what is the prediction? If the blood pressure increased by 10 mm, 10 mm increase in the blood pressure, the risk score will increase by 7 times. This is the working portion. Okay, based on the assumption. This is how it is estimating. Next, what it is doing, cholesterol level. Last term is cholesterol. 10 milligram for every 10 milligram per deciliter. Deciliter is the unit for measuring the cholesterol in the blood. That means 240 milligram per deciliter means what is the meaning? 0.1 liter of blood contain 240 milligram of cholesterol. This is the meaning of this unit. So every 10 milligram increase, the cholesterol will increase, the cholesterol score will increase by +2. Then cholesterol not increase, cholesterol based scores will increase by +2. What is the actual value of cholesterol? +2. What is the actual value of blood pressure? +7. What is the actual value of age? +3. Based on the age difference. Or based on the base value, 1 year excess means +3 will be added. 10 is deviated means +7 will be added. 10 is cholesterol level, 10 is deviation means another +2 will be added. Based on that only the predictions will be calculated. Okay. I think it is understandable. Now, use S1 equation. The weights are already estimated 3.7 and 0.2. So what we are doing, B plus 54, how 0.7, 0.2 means here it is. W3 is 2, that is 0.2. This is 0.7 mm of Hg. That's why it is converted into this. Age will be maintained as it is. Okay, these things are, I think it is clear. So 54 into 3 plus 130 into 0.7. These are per deciliter per Hg. For that only we are converting that into corresponding scaling is done. So 3 into 0.7 plus 0.2 is equal to how much? 68. Okay. So now what we are doing, this is the detailed calculation. We are getting now bias we are going to calculate. For this predicted weights, predicted score, what will be the bias? Bias is equal to -233 we are getting. Now what I am doing, I am going to fit this in the local model. So minus 233 plus 3 into x1 plus 0.7 into x2 plus 0.2 into x3. Now my local model final line prediction equation is ready for analyzing any data. This is the model created by line. Whatever instant you are giving, it will put in that value into that. Let us check. So x naught is 54, 130, 140, right? So what it is doing, 3 into first parameter, 54. This set you can vary. On different data, you can vary and verify. This is called a prediction. So 0.7 into 130, 0.2 into 240, everything minus 233 is the bias. So if you add all the things, what you are getting, 68. So matches the black box prediction. For this value, what we are getting, actually this value will come since the bias is scaled down. Based on this value only, bias is calculated. Now you understand this bias is not fixed by an unbiased system. This bias is not fixed. It will increase or decrease based on this parameter. So balancing this, automatically this value will match to you. Fine. So for this patient, what are all the different things you have calculated? Plus 162, where it is here, plus 162 plus 91 plus 48, bias is minus 233. So total is nothing but 68. This is how the model is predicting. But what you understand, age is 162, blood pressure is 91, and cholesterol is 48. These are the contributions of different parameter. In this prediction, highest contribution is age. Based on the age only it is telling. Next highest preference is given to blood pressure. It will check the blood pressure. Next only it will comes to cholesterol. So based on these three parameter, this baseline is lightly adjusted so that we are getting the value of 68% of hot prediction. This is how. So age is the strongest local factor. Blood pressure is the second highest value. Cholesterol also contributes, that is plus 48. So bias adjusts the model down so that the total value is what? 68%. Okay, so this is called as tornado chart. So here also you can check age is the highest parameter. Next preference is given to blood pressure. Next least preference is given to cholesterol. In that manner, you can check different models. You can compute this for different datas and check what are all the different contributions each and parameters are holding. If you contribute for next set also, you will get the same thing. So if possible, we will do that calculation for different data also, if possible. So here, let us check. Quickly, I will do. You can consider another set of data. What are the data available? I can check. Since already model is, I will take S5 model, 54, 120, 240. Okay, that I will take now. 54, 120, 240. This deviation. Okay, so here 54. Okay, this is 120 and this is 240. This data I am going to check. For this also, age is the highest factor, means our prediction is correct. Fine. So one instant, age is the highest contributing factor. Based on the age only it is telling. So for this also, age is the highest contributing factor, means definitely the model is partially working. Similarly, you have to check all the model manually. System will check, but for our convenience, we are checking. Okay. So what we are doing, simply we will put this in the, first we will calculate the weight bias. Then we will come here. Okay, 54, 120, 240. So bias we need to calculate here. 54 into 3. 54 into 3 plus 1. Oh, sorry. Where it gone? Okay, 54 into 3 plus 120 into 0.7. Sorry, I am not having pen, so please adjust. Okay, 120 into 0.7 plus 240 into 0.2. There is no change. Okay, only change is this only. So 240 into 0.2, and I need to check what is the prediction value. So that is the main thing. 240 into 0.2. So what is the prediction value you are having for the values? 54, 120, 240. Okay. 54, 120, 240 is sample 5. For sample 5, we are having the value 60. So here it is nothing but what? 60. So this is plus B plus. So we can use calculator and you can find out what are all the things available. So 54 into 3 is 162. There is no change. 120 into 0.7 we need to calculate. So 120 into 0.7 ink annotations. Okay, you can do here. I will take the calculator for instance. Okay, so roughly I will calculate 120 into point. So 54 into 3, this is not changing. Here 120 into 0.7. 120 into 0.7. That is the only change, right? So 120 into 0.7 is nothing but 84. So this value will become 84. 1 minute. Okay. So this value is okay. This value becomes 84. Sorry. This value becomes 84. There is no change in this value and this becomes 60. Okay, so this becomes 60. This is the only change. So B plus 301. 30 sum is sum of this. Okay, sum I have to do, right? So 162 plus 84 plus 48. I will compute here. 162 plus 84 plus 48. What answer you are getting? 294. This is nothing but for the new value, you are getting the instances 294. And here what we have to do 60 minus 294. So I am putting minus 60. 60 is the new prediction, right? So I'm getting 234. This is nothing but minus 234 is come. This is what the minus 234. Now the value is over. Remember the bias value minus 230. So what I am doing, I am going to check all these data. What data we are getting previously 162. This becomes previously we have to take the values. Okay. So this thing is parallelly we will calculate so that it will be good for you. So this value now change 54. So you need to check 0.7 into 120. That is 0.7 into 120. 0.7 into 120. Sorry. 0.7 into 0.7 into not coming well 0.7 0.7 into 120. 0.7 into 120 is 84. Okay. 120 new value is 84. This value no change. This value what we are computing 84 already we are did. And this value is minus 234. Okay, minus 234. This value is minus 234. If you put all this value means automatically what you will get 60 only, no change. So we will check this. So 162, right, plus 84 plus 48 minus 234. Automatically 60 will. No change. So this is 60. This is nothing but what we are getting in the prediction. So here, what are all the contributing factors? You can check 162 will be common. This become 84. This become 48. Weight is now reduced to how much? That is the thing, minus 234. Now it is, weight is just biased. Bias is just adjusted. So the prediction will be what? 60. So here also, what is the parameter, contribution parameter? First one is the age, second one is the blood pressure, third one is the cholesterol. No change, only variation in the values, but the prediction will be same. Highest contribution factor is what? Based on that, you can tell highest contribution is age. Next highest contribution is blood pressure. Next highest contribution is cholesterol. It is checking each and every samples and it is justifying that based on the several instances, I come to the conclusion that based on the age factor, I am telling that you are having this much percentage of heart disease. So I am first checking your age. Next, I am checking your blood pressure. And then next, I am checking your cholesterol. So highest contribution is age. Next is your blood pressure is normal, that is medium, and cholesterol is low. So what you have to do, age is increased, we cannot do anything. So what you have to do is you need to maintain a stable blood pressure and you have to maintain a stable cholesterol. So blood pressure maintenance, you have to do regular walking. Cholesterol means you have to maintain a regular heating habitations so that you will have a normal, you will have a stabilized maintenance of your health. This is the prediction given by the system. Like that manner, we have to explain. This is how the Lime is explaining individual instances and justifying that a linear model is making a prediction perfectly or not. This is how the local interpretable model agnostic explanation is working. Hope my explanation is understandable to you. So in the upcoming classes, we will see global interpretation, that is called Shape values, how the Shape values are formed, on what basis the predictions are done. That we will do in the next upcoming lectures. So thank you all once again for learning my uh, class. With that, I am stopping. Good luck and good wishes to all. Thank you, everybody.